So now we're going to look at factoring trinomials, and we have two types that we look at. You have the ones that I call plain Jane trinomials, where a equals 1, so it starts with just an x squared. And then you have the ones where a is not 1, so maybe 3x squared or 5x squared to start off your trinomial. But first we're going to look at multiplying polynomials. So if I wanted to multiply x plus 3 times x minus 1, I would use FOIL. So first, x times x gives us x squared. Outer, x times negative 1 is negative x. Inner, 3 times x is 3x. And last, 3 times negative 1, negative 3. I have my like terms in the middle there. So negative 1 and positive 3 is a 2x. So we get x squared plus 2x minus 3. Factoring these trinomials wants to get me back where I started here. I want to get back to x plus 3 times x minus 1. So whenever it's a plain Jane trinomial, because I have a 1x squared, I'm going to multiply to my c value, add to my b value. So I get those two numbers, the positive 3 and negative 1, and that's what I put in my parentheses. So for some examples, the first one, my c is a negative 6 and my b is a negative 5. So I want to multiply to get negative 6 and add to get negative 5. So multiplying to get a negative means one of my numbers is negative and one of them is positive. And then I want to add to that negative 5. Well, my factors of 6, or of negative 6, are going to be 1 and 6, and 2 and 3. And I want one positive, one negative. So that means the 2 and 3 is out, because if one's positive, one's negative, that's going to give me a 1 or negative 1. So I'm going to use the 6 and the 1, and I want my them to add to get a negative, so my bigger number to be negative. So x minus 6, x plus 1. For the second example, I want to multiply to get a positive 45 and add to get a positive 14. So because I'm working with all positives, my numbers are all positives in my parentheses. I'm going to have x plus something times x plus something. Some factors of 45, we've got 1 and 45, 3 and 15, 5 and 9, and that 5 and 9 would add to get 14, so I have x plus 5, x plus 9. Right? Order doesn't matter, right? We're multiplying. 5 times 4 is the same as 4 times 5. So you can write it x plus 5 times x plus 9 or x plus 9 times x plus 5. That part doesn't matter. They're the same thing. Right? Then we go into trinomials where a is not 1. So the first thing you always want to do is look for that GCF, because sometimes you may think it's not a plain Jane trinomial, but if you factor out a GCF, it becomes a plain Jane trinomial. So for our first example, we have 2x squared plus 3x plus 1. 2, 3, and 1 don't have anything in common other than 1, so there is not a GCF. And so for the first round, we're going to do these again in a minute, I'm going to do it with bottoms up, or also called slide and divide. It's just a shortcut to help you factor it, and it works every time. So for bottoms up, step 1 is I want to make this a plain Jane trinomial, because that's easy to factor. So I'm going to take my a and just temporarily move it to become part of c. I'm going to do that by multiplying. So I have x squared plus 3x, and then 2 times 1 is 2. So x squared plus 3x plus 2. Now I've got a plain Jane trinomial, which is what we just factored. So I'm going to go straight to my parentheses. I'm working with all positives, so I'm going to have pluses in my parentheses. And I want to multiply to 2 and add to 3. Well, that's going to be 2 and 1. But now I still have to take into account the fact that I moved that a to make it part of c. So I'm going to take it back out by doing the opposite operation. So I multiplied to get it there. Now I'm going to divide to take it back out. So I'm going to divide both of these numbers by my original a, which was 2. And then I'm going to simplify. So 2 divided by 2 is 1. And 1 over 2 can't be simplified. It's just 1/2. Right? Now when we factor, we can't have any fractions. So this is where the bottoms up part comes in. I'm going to take the bottom of that fraction and move it up in front of my x. So this becomes x plus 1 times 2x plus 1. And then there's my final answer. So for our second example, I've got 27 and 6. There's no GCF there. So I'm going to start by multiplying a and c. So we get x squared plus 7x minus 120. So now I want to multiply to a negative 120 and add to a positive 7. So I have one positive, one negative. And so those numbers are going to be 15 and 8. Right? And I want the bigger one to be positive because I want it to add to a positive number. So you have a positive 15 and a negative 8. And again, I'm not done yet. I'm going to take out that original a value, so I'm going to divide by 20. And then we simplify. So 15 over 20 simplifies to 3 over 4. And 8 over 20 simplifies to 2 over 5. And again, no fraction, so we have to do bottoms up. So take both of those since I had two fractions this time. And we get 4x plus 3 times 5x minus 2. There's also another method called reverse box that you can use. I don't care which one you use. I would just recommend picking one and sticking with it every time, because you don't want to have to keep going back and forth, because both of these methods work. Now, reverse box goes along with the box method of multiplying. So if you remember, if I wanted to multiply x plus 2 times x minus 1, you make your box, and then you multiply x times x times 2, x times negative 1, and then 2 times negative 1. Your like terms, if you have any, are going to be diagonal. So then we get positive x and negative 2. All right, so now we're just going to do that same thing but backwards. All right, so to start with, these are the same two examples we just did with bottoms up. So I'm going to start by first finding that magic number before I even do anything. So I'm going to multiply a and c. So I'm going to multiply 2 and 1, and we're going to come back to this number in a minute. Then I'm going to draw my box. And I know that whenever I multiply, my first term, the a term, is always in the top left. So I can go ahead and put in 2x squared. And then the c term is always in the bottom right. So I can go ahead and put in my plus 1. I just have to figure out what goes in these two boxes. And to do that, I want to multiply to my magic number, 2, and still add to that same b term, 3. So that's going to be a positive 2 and a positive 1. So I'm going to put a 2 and a 1. But remember, these diagonals make that b term, so they also have to have the x value. Once you fill in your boxes, we're going to work away from that bottom corner and just find our GCFs. So the GCF with 2x and 1 is 1. 2x squared and 1x is x. 2x squared and 2x is 2x. And then 1x and 1 is 1. Then you just write your binomials in parentheses. So we have a 2x plus 1 times x plus 1. All right, over here, I'm going to do the same thing. I'm going to start by finding that magic number, a and c, which is going to be a negative 120. And I'm going to draw my box. My a term can go in the top left, my c term in the bottom right. And then for these, I want to find two numbers that multiply to the magic number negative 120, but add to that positive 7. And we said that was 15 and 8, 15 and negative 8. And then you put your x's in there. And we work away from the bottom corner. So you have negative 8x and negative 6. Now remember, you always keep the GCF of your first number, the first number you come to, or in this case, the top, so negative. So that's going to be a negative 2. 20x squared and 15x is going to be 5x. 20x squared and negative 8x is a 4x. And 15x and negative 6 is a 3. So then I have a 5x minus 2 and a 4x plus 3. And for the last part of the video, we're going to review solving by factoring, which we did a little bit already. But remember, to solve by factoring, it's got to be set equal to 0. So if it's not, you need to first move everything over to one side so that it is set equal to 0. And then this one was one we already factored. We wanted to multiply to 45 and add to 14. So we said that was x plus 9 and x plus 5. So this has been factored now. To solve, in order to multiply to get 0, at least one of these numbers has to be 0. So I have two options. X plus 9 can be 0, or x plus 5 can be 0. And then to solve for x, we subtract 9 and subtract 5. So then my answer becomes negative 9 and negative 5. And then for example 2, this is also one that we factored, and we factored it to be 2x plus 1 times x plus 1. And again, set them both equal to 0. The easy one is just to be able to subtract the 1, so I get a negative 1. This one's just a two-step. So I subtract the 1 first, then divide by 2, so I get x equals negative 1/2. So then my solution becomes negative 1/2 and negative 1. So to solve by factoring, factor like normal, then take it one step farther and set all of your factors equal to 0.